Hi guys, how are you?
Hello, Marjan. How are
Hi,
you?
how are you? I'm good.
Good, thank you. So I just want to talk about what we have done so far. I want to talk about the ABC algorithms. So this week, just last week and this week, we worked intensively on tuning the artificial bee colony algorithms to find the best blending parameter alpha for our assembled model. The goal was to optimize the balance between random forest and logistic regression outputs. By carefully adjusting alpha, I aim to improve the model's sensitivity, particularly for minority classes like suspect blood donor, which had lower recall rates. The tuning cycles have shown early improvements in recall. But inconsistencies are still present for some minority classes. Each adjustment requires testing multiple cycles to confirm that we are achieving the desired balance without causing overfitting or reducing accuracy in other classes. I plan to continue refining the balance over the coming days with a particular focus on stabilizing recall for these critical classes. Samana, would you please just talk about cross-validation implementation?
Yes, yeah. And also, I focused on setting up and running five-fold stratified class validation to ensure that all classes, especially minority ones like hypothesis, are proportionately represented in each fold. This step is essential to validate our model performs consistently across diverse data splits. However, the cross-validation cycles have been computationally demanding, slowing down progress on other tasks and delaying our ability to validate tuning adjustments quickly. To address this, I've started optimizing the code to reduce the computational load and increase efficiency. Once the optimization are in a place, I'll be able to run more cycles within shorter time frames, so which is critical for testing the impact of each tuning adjustments on minority detection. And how about the performance metrics analysis, Mahmoud?
Uh,
Can
yeah,
you
of
please
course.
explain it?
Sure. I focused this week was on analyzing the model's performance metrics, precision, recall, and F1 score after initial ABC tuning. Our adjustment has shown improvement in minority class detection, but further adjustments are needed to find a balance between recall and precision. Particularly for classes like cirrhosis and hepatitis, we analysis has shown uh, where the model performance well and where adjustment might still be needed, specifically in stabilizing minority class metrics. We are not testing different parameters combination in the ABC algorithm to ensure that we are not compromising overall model accuracy while trying to improve minority class performance.
So perfect. I'm going to talk about our challenges and problems. Just want to start. The difficulty in stabilizing sensitivity and for monetary classes. One of the main challenges I faced this week was achieving a consistent sensitivity for minority classes while fine-tuning the alpha parameter in the ABC algorithms. The balancing parameter alpha is crucial as it determines how random forest and lattice regression contribute to the final output. Adjusting alpha affects the model's sensitivity and recall for minority classes, particularly suspect blood donor and cirrhosis. Even slight adjustments to the parameter can lead to either overfitting or a decrease in accuracy for other classes. This issue has required testing multiple parameters value and running several validation cycles to confirm each adjustment's impact, ensuring that these adjustments do not compromise model stability across classes has been challenging, and it requires a fine balancing between precision and recall to meet our goals. Samana, can you just talk about the high computational demand in cross-validation cycle?
Yes, Marjan. And the second one, yeah, as you mentioned about high computational demand in a cross-validation cycles. Implementing five-fold stratified cross-validation was essential for ensuring balanced class representation in each fold, but it has presented a significant computational challenge. Class validation requires multiple cycles of training and validation across different data splits, and each cycle places a high demand on processing resources. As a result, the time taken to validate each tuning adjustment has slowed down, affecting the overall workflow and delaying our ability to test the ABC tuning adjustments quickly. Running additional cross validation cycle also means that any inefficiency in the code compounds, which further impacts the project timeline. So to address this, I started working on optimizing the code, reducing the computational load by eliminating redundant calculations, and also streamlining data handling within each cycle. However, this optimization is still ongoing, and managing computational efficiency remains a critical challenge in our project. And the third one is about balancing precision and recall without overfitting. Mahmoud,
I will explain it. Sure.
okay.
Okay. Our challenge this week has been to find an effective balance between precision and recall for minority classes like hepatite and cirrhosis without causing overfitting. As we continue tuning the ABC algorithm, small parameters adjustment often have accuracy and can lead to overfitting. Where the model performs well on training data but fails to generalize effectively to unseen data. This issue has required extensive testing to confirm that change uh, in metrics such as recall and precision are really improving the model's ability to detect minority cases and not just a result of overfitting. Additionally, validating this balance across multiple validation cycles has been time intensive as we need to ensure that each adjustment holds consistently across different folds of data. Achieving this balance is essential for the model's success in real-world applications, but it requires accurate tuning the validation.
Okay, perfect. So I'm gonna talk about what are our achievements. So initial improvements in minority class recall through ABC algorithms and ABC tuning. A key achievement this week was improvement in recall of minority classes, such as suspect blood donor and cirrhosis, through targeted tuning of the ABC algorithms, blending parameters alpha. By adjusting alpha, I was able to find the initial balance between random forest and logistic regression that improved the model sensitivity to these underrepresented classes. So this tuning has led to a noticeable increase in recall for minority classes, helping to bring the model closer to our target accuracy across all the classes. Also, further adjustments are needed. This improvement marks a significant step in optimizing this ensemble model for balance detection capabilities, ensuring that the model performs well even for challenging low frequency cases. Achieving this initial balance was a complex task, but the result affirm that our assemble approach is effective and can be further refined. And Samara, can you please just talk about successful implementation of 5K fold?
Yes, yes. This week I successfully set up and run five-fold stratified cross-validation, which is critical for validating the model's performance across different data splits. Stratification ensures that each fold contains a proportional representation of each class, particularly the minority classes, which help us accurately evaluate the model's reliability. Implementing this cross-validation approach has given us confidence that our performance metrics reflects a more generalizable outcome. This step was computationally demanding, but it provides a more robust validation frameworks, enabling us to test the impact of tuning adjustments more accurately. Furthermore, tuning efforts are insights gained from running these validation cycles have been invaluable in confirming that our ABC tuning efforts are move the model in the right direction. And how about the identification of a key performance metrics and areas for further tuning? Mahmoud, can you speak about
Yes,
this
of
topic?
course. Yeah. Um, our work in analyzing precision, recall, and F-bound score metrics across classes has led to the identification of a specific performance area that need further attention. Through detailed analysis, we was able to pinpoint which metrics, such as minority class recall, require additional tuning to achieve the balance we are aiming for. This insight is crucial as it provides us with a clear roadmap for future adjustment and helps us avoid unnecessary change that don't contribute to our project goals. By closely monitoring these metrics across validation cycle, we confirm that the adjustment made so far have positively impact a minority class detection rate, giving us a more reliable basis for continued improvement. This analytical approach has allowed us to make informed decision about tuning priorities and has strengthened the model's foundation for robust, accurate performance.
Okay. And how about what are our next plans for the next week? One of our next plans is about, we want to continue refining the ABC algorithms alpha parameters, focusing on adjustment to further improve minority class recall without affecting overall accuracy. And the second one aimed to finalize code optimization to make cross-validation more efficient, allowing for quick validation of model adjustment. And also, we will complete this analyze and prepare a summary of findings to inform the team on which areas of model performance need further attention. So, thank you everyone. So for
Yeah.
summarize of this
Thank you.
meeting, I think we've made progress in tuning the ABC algorithm, implementing balanced cross-validation and analyzing performance metrics for minority classes. So while challenges remains in stabilizing sensitively and managing computational load, each team member has defined clear next plan to address this issue. So over the next week, we'll continue refining the model, optimizing validation cycle, and documenting our adjustment to ensure a balanced and accurate final model.
Thank you,
Okay.
guys. Thank you. Thank you.
Thank you,
Have a good
guys.
day.
Thank
See
you.
you.
Thank
Bye.
you. Bye.